Okay, so there goes my scoreboard's dying on me. Anyway, like I was telling you before, grades are in the grade book. Okay, chapter 7. We're going to start today. We're going to skip all the 7 1s. Okay, we're going to get into the 7 2s. We'll do that basically over the next 2 weeks, going into spring break, towards the end of the quarter. Then after spring break, when we start the 4th quarter, we will come back, and then we'll kind of finish up the rest of the chapter. So that's where we're at. Test-wise, again, like I said, your grades are in there. If you did not take the test yet, and there's still plenty of people who have not yet taken the test, just this morning I put people in for ELT for this Friday to come and take it, unless you talk to me individually and you schedule a different time. Like one person's already done it. One person's coming in today already to come take it, okay? Which is fine. That's fine as well. I just want to make sure that it gets taken this week in particular, so that those grades can get in the grade book and then be calculated for your 3rd quarter grade, okay? So that's that. Couple of things. If we then take a look, I handed out, the first packet that I handed out to you was, this is your chapter 7 practice to learn packet, okay? So this is all of chapter 7. These will be the worksheets for like the next 2 weeks, plus probably 2 to 3 weeks after break as well, is we'll be using these. What I want you to do real quickly is, hopefully you still have that out. The second packet that I handed out to you is actually the lesson for today. But while you have your homework packet out, what I want you to do is flip it over to the back side, the lesson packet for today. Because I just got done telling you that we're not doing the 7 1s, but if you notice, the very first one listed says 7 1 4. What we decided to do is pick a few problems out of 7 1 4 and a few problems out of 7 2 1, and that's your first assignment. So what I want you to do is circle the problems listed on the back here, okay? So in your homework packet, circle problem 745, 747, 748. Those are these are the only ones you have to do. You do not have to do the other ones, okay? In 721, make sure you circle 754 and 759. So those 5 problems are your first assignment. Okay? It's in a combination of 714 and 721, but those are the only problems that you have to do for your first assignment. Okay, so just a heads up on that. Then you can take that practice to learn packet. You can put that away. You don't need that today. And what I want you to do is take the lesson packet, go to the back of the front page here, and your warm-up is right there. I'll give you a few minutes to work on your warm-up. Okay, 721 warm-up. Go ahead and do those 2 problems, and then we will come back together. And it looks like my projector is not working today, so we'll just be using the whiteboard. I'll just draw everything up here. All right, let's come back together and kind of see where you're at on this stuff. See what you came up with. Like I said, smartboard apparently is not working today, so we're just gonna use the whiteboard. So first problem, just going back and reviewing again the idea of solving a proportion, specifically when there's a binomial. Okay, remember when you solve a binomial proportion, you got to think of that as a quantity. So when you cross multiply, don't forget that the 3 needs to get multiplied by both parts. Okay, that's usually the number one mistake. People multiply 3 times y, but forget to multiply 3 times the -2. So when you do that diagonal, you should get 3y minus 6 equal to the other diagonal, which is 6y, and now you solve the resulting equation. Get all the y's together. So I'm going to subtract the 3y over. So I've got -6 equal to a positive 3y. And we solve for y, divide both sides by 3. Oops, positive 3. And y equals you end up with a -2 as an answer. Okay, so that's what you should come up with for that first one. When you cross multiply and solve the resulting equation, you end up with 2 as an answer. Problem number 2, I asked you to find the perimeter, okay, of this shape. And so the one thing you really had to find is you had to figure out, if I put an X in here, I had to find that side length in order to get my perimeter. And the question is, how do I go about it? Okay? So let me kind of open it up to you. What'd you do? What'd somebody do in order to start this problem? Step number 1, what would you try? How do I find X? What do we think? Here? Do we know for sure it's a 45, 45, 90? You're talking about this one? Yeah. Right? For sure? I got the 90 for sure, right? We don't. Unfortunately, I don't know for sure that this is 45, 45, 90. Okay? It might look like it. It kind of does look like it. But there's no way to know. It doesn't tell you that the 2 legs are congruent. It doesn't tell you that these 2 angles are congruent. Therefore, I don't know for sure that that's 45, 45, 90. So unfortunately, that's not going to work out. Adele, what do you think? Okay, you're on the right idea. Yep. So if we take a look, instead of working on this triangle right now, because I really don't have enough information to do anything, I would need one of these angles, or I would need another side length or something in order to work on that triangle. I'm going to take this dotted line and kind of slide it over here, because the height here is going to be the same height over here. So if I go through and let's say I add a height in, those will be the same, which means if this is 4, that means this piece right here has to be 4. And like Adele just said, that means the rest of this must be 6. Now tell me something else you know that has to be true. Something else in the picture that should lead you to something else. What do we see? What do we see? That's exactly what it is. Because I slid this over and it's perpendicular here, it's still going to be perpendicular. So this is a right triangle, and I know 2 of the sides. So you can either do Pythagorean Theorem, or if you know, this is a Pythagorean triple off the top of your head. So that means this height right here has to be 8. That is a 6, 8, 10 triangle. Okay? Which therefore, now if I start working my way back, if this is 8, that means back over here, this must be 8. And now I do have enough information in this right triangle to solve for X. Now I got a right triangle, I know 2 sides, I can do Pythagorean Theorem in order to get it. Okay? So in this case, we would have x squared plus 5 squared equal to 8 squared. There's your Pythagorean Theorem setup, leg squared plus leg squared. Square everything out, we get x squared plus 25 equal to 64. Subtract the 25 over, and we end up with x squared equal to 39. And then finally, we take the square root of both sides, and you should get 6 point something. Somebody have it for me? What'd you get? 8.24. Okay, thank you. That sounds right. 6.24 is what you should end up approximately for X, for that missing side length. And now I have all the information I need in order to find the actual perimeter. Now I just got to put it all together. So the perimeter of this shape, we've got 4, 10 more puts you at 14, 10 more here puts you at 24, 5 more puts you at 29, plus the side we just found, which means we're at 35.24 meters. And there is the perimeter for this shape. So this problem was more just trying to find those different missing parts, finding different relationships that you could use in the picture in order to get to that point. Okay? How are we doing? Making sense, hopefully? Questions on anything? Okay. So now, if you go into the packet then, if you take a look at the next page, now we're going to get into the actual, like I said, the actual kind of part of the lesson here. And like I said, what we're doing is we spent 4 chapters talking about triangles, similar triangles. Then we went into sine, cosine, tangent, law of sines, law of cosines, all that information. And then just last chapter, we were looking at congruent triangles and then proof. Okay, but The last 4 chapters have all been about triangles, and the reason why we spend so much time is because now we move into the second part of geometry, which is, let's start building things with those triangles. So we're going to go from triangles now into quadrilaterals, and we're going to start looking at triangle properties. We're going to start building those quadrilaterals, okay? And so this is what we're going to be looking for. That's why this page is here. This is basically a summary of the next 2 weeks, which we're going to look at side lengths. Do we have any parallel sides? Do I have any congruent sides of the shapes that we're looking at? Then I'm going to go through and we're going to look at angle measures. Do I have any congruent angles? Do I have any supplementary angles? That's what I'm looking for, okay? And then we're going to add in the diagonals and start looking for, are they congruent? Do they bisect each other? Are they perpendicular? These are the different things that we were looking at. We're not necessarily going to spend nearly as much time on actual proof, but if you notice at the bottom, I said, be sure to justify the properties using congruent triangles and angle relationships, okay? So you need to be able to back up how you know something is true, okay? So if you take a look at the next page then, we are going to get into, first 2 shapes we're going to take a look at are properties of a parallelogram and properties of a kite, okay? Those 2 shapes in particular. And what I'm going to have you do, the first thing, I'm going to have you kind of work back and forth between your toolkit and this sheet, okay? This sheet here. I want you to kind of do the work on the lesson sheet. That's why I gave you that. And then we'll copy over a little bit cleaner information onto your toolkit so it's not super messy. But the first thing I do want you to copy onto your toolkit is the definition of a parallelogram. Okay, put that right below where it says parallelogram on there. Definition, it's a quadrilateral with opposite sides parallel. Put that one on your toolkit. Okay, so we've got a definition first. So it is a quadrilateral, meaning quadrilateral, 4-sided shapes. That's what we're looking at this chapter, okay? So we have a 4-sided shape, and what makes it special is that opposite sides are parallel. Thus, the reason why it's called a parallelogram. On your toolkit, again, what I want you to put in there, we're going to put just the markings as well. So I'm going to put the parallel lines in here. Right there is your definition of a parallelogram as a picture. Okay, 4-sided shape with opposite sides parallel. And that's all I want you to do for now for the picture. Okay, now let's go back to the lesson. And we'll, like I said, we'll then copy some information down here once we figure out what it is. But I don't want you to get your toolkit all messy and have all kinds of stuff. I'd rather you do the work on the lesson and then come back and just put the cleaned up version here. All right, so let's take a look. So we are going to talk about 4 or 5 different properties, okay? First one, we've talked before that anytime you see parallel lines, we've talked about angle relationships. What are the 3 parallel line angle relationships I should be looking for right now? What are the different names of the angle types? Huh? Corresponding is one of them. What's another set? The next 2 kind of go together. Ella? Alternate interior, or if they're not alternate, they are same side interior. So remember, corresponding are the ones where you slide it. It's a translation. Alternate interior is where you're looking for that letter Z. And same side interior is where you're looking for the letter C. And we know those are supplementary. What do I have right now in this picture? Which one of those 3 do I have right now? Huh? Same side. Yeah, we've got same side interior. I'm going to kind of highlight it just for a second. Here's the idea right here. There's your letter C right there. those two angles have to be supplementary. And let's say I go through and I look at these two angles. I could do the same thing this way if I wanted to. The letter C again. Those two angles have to be supplementary. Matter of fact, if we just keep going, these two angles have to be supplementary because they're same side interior. Those two angles, okay, which is going to kind of lead us to our first property that I'm going to put down. And property number one that I'm going to add in here is consecutive angles are supplementary. I'm just going to abbreviate SUPP. Consecutive angles are supplementary. What does the word consecutive mean? Like, what am I getting at? What am I describing when I say if two things are consecutive, what does that mean? Because I can use that term, but if it doesn't make sense, then it's kind of useless. Not necessarily repeating, but you're on the right track. Consecutive means one right after another. If numbers are in consecutive order, it'd be like 1, 2, 3, 4. So in this case, the way consecutive applies to this picture, if I pick an angle, regardless of which direction I go around, the next one is supplementary. So if I pick that angle, that one's supplementary to it. If I go this way, that angle is supplementary to that one. Okay? So that's the idea. Two angles that are right next to each other are supplementary because, matter of fact, I'll even put this in parentheses here, because they are same side interior angles. That's the reasoning. That's the corresponding angles, or the consecutive angles, are same side interior. Which, let's take it one step further then. I'm going to get rid of this for a second. Let's take it one step further. What does that mean about the opposite angles then? What has to be true? How does that angle have to compare to that one then, based off of what we just talked about? What do you think? Aiden, what do you think?
Alternate interior.
They're not alternate interior. Nope.
Corresponding.
They're not corresponding either. Okay, matter of fact, so the only thing we actually have in this picture, at least right now, is the same side interior. Because otherwise, if I took corresponding, for example, if I took this one and I slid it up, it would actually go right there, which now it's outside of the parallelogram. Same thing here. If I slid it this way, it would correspond with this one that's outside this. Okay, so those two, it doesn't quite work. But let me give you an example. You'll see it, and then I'll get rid of the numbers for a second. Let's say I tell you that this angle right here is a 50-degree angle. I'm just going to make something up. Therefore, based on what we just said, what does that angle have to be? Got to be 130. Okay? Based off of that angle, what does this angle have to be? 50. Based off of that angle, what does this angle have to be? Now, let me ask you again. What do we know about angles, opposite angles in a parallelogram? Now you should be able to see it. How do they compare? Connor? Yeah. Consecutive angles are supplementary. Opposite angles are equal to each other. Okay? There's our next property we're going to put down. Opposite angles are congruent. Consecutive ones are supplementary. Opposite ones are congruent to each other. And like I said, I just made up some numbers just to kind of fit so that you had an idea of what was going on there. All right. So we've looked at angles. We found which angles are supplementary, which ones are congruent. We've looked at that. Now I'm going to switch this over to kind of start looking at side lengths a little bit. So I'm going to get rid of this. And what I want you to do in your picture then in the lesson is I'm going to add a diagonal. And the one I'm going to add, it doesn't really matter which one, but I'm going to add the longer diagonal. Okay? Because this is kind of slanted to the right, that makes this diagonal the longer one. So there's my longer diagonal. And we already said we know that this angle is congruent to that one. That's what we just talked about. Now, tell me something else that's true in this picture. Picture's changed a little bit now. Hopefully you see two triangles. Tell me something you know about those two triangles. We know. Think about the stuff we've talked about. Still thinking of parallel lines. Start thinking about congruent triangles, that idea that we just came out of the last chapter. Let me ask you this. I'm going to kind of go back to what Hayden was talking about before. If I take this angle right here, which angle does that have to be congruent to? This one right here? Why? Why, Amanda? Now, by me putting that line in there, now there's the letter Z right there. Because the top and bottom are parallel, those are alternate interior angles. So those have to be congruent. And now if I go a little bit further, if you think about it from a proof perspective for a second, isn't this a shared side? Right? So this one is congruent to itself. You tell me now, are those two triangles congruent to each other? Why? Which shortcut did we end up with at this point? Back there? Yeah, we've got angle, angle, side, which means, and here's why we ended the last chapter where we did, if those two triangles are congruent, don't I know then that all of the corresponding parts are now congruent? Wasn't that whole CP-CTC idea that we talked about? Well, I just proved the two triangles congruent, so here's a whole bunch of extra information that I now know. That means, and these triangles, if you see them, they are rotations of each other. Okay? They are not reflections, they're rotations. That means this top side right here, that would rotate down to here. That means this side is congruent to that. The left side would match up, would rotate over here. That means that side is congruent. If we wanted to, I could now say that I know that this angle has to be congruent to that angle. And we've got all of those different parts that are there. Okay? Now all the corresponding parts match up, which means I'm going to add in another property. Okay? There are two things. We talked about opposite angles. There are two things when it comes to the opposite side lengths. One of them is just is the definition of a parallelogram. So it should be pretty obvious. Opposite sides are parallel. And what did we just prove? What else do we know about the opposite sides of a parallelogram? Not only are they parallel, they are also what? Congruent. We just proved it. Top and bottom have the same length. Left and right have the same length. Very similar to that of a rectangle, that idea. So not only are they parallel, they are also congruent to each other. All right, I got one more thing for a parallelogram. And in order to wrap this one up, I'm going to add in the other diagonal. Hopefully you can kind of see why I told you not to go on the toolkit and not put all the markings in. Because if you've got all of these markings on the toolkit, there's so much there, you probably don't have any clue what's going on at this point. That's why I'm doing it on the sheet of paper, not on the toolkit. But if we add in now the other diagonal, we could once again take a look. I've got a bunch of vertical angles here. I'm going to get rid of this for a second. So I know that this angle right here, I'm running out of little dashes, and that angle are the same because they're vertical, which means if you see a top and bottom triangle, angle, angle, side, okay, angle, angle, side, same idea here. That means these two triangles are congruent. I could actually do the exact same thing for these two triangles. So now I've got two sets of congruent triangles, which here's the point I'm trying to get at. If this triangle is congruent to this one, okay, that means this side length right here would rotate down and match up with that side length. This side length here would match up with this side length. And what I want you to notice is this. This is kind of what we talked about this in proof. If these two segments are equal, what does that mean about this point right here? It's got to be a midpoint. And if you look the other way, those two segments are congruent as well. So here's our last property that I wanted you to notice. And notice that we're getting all these properties from congruent triangles. Knowing that triangles are congruent is helping us a lot with this. So last property that I want you to put down is the diagonals bisect each other. The two diagonals cut each other in half. They're not all equal, but they do cut each other in half. It's that point of intersection is the midpoint for each diagonal. Now what I want you to do, if you haven't done it already, take those four properties and put them on your toolkit. Okay? Don't put all the markings in on the picture, but take these properties and put those on the toolkit if you have not done so already. I'll give you a second to do that. And we're not going to have necessarily a ton of time to go through extra examples of where this is going to work. But the idea is, now if I were to give you an angle measure, you should hopefully be able to find some other angles. If I gave you a side length or part of a diagonal, you should then be able to find other lengths using these properties. So you're going to use the properties to solve for different lengths and different angle measures. All right, let me clean that up and go to the kite part. I'll let you write that down. And let me go to the kite portion. Kite is a whole lot simpler. Once again, go ahead and put the definition of a kite right on your toolkit right away. It's on the next page. Okay. Definition of a kite is it is a quadrilateral, four-sided shape with two distinct pairs of consecutive congruent sides. And I'll show you what that means in just a second. A quadrilateral with two distinct pairs of consecutive congruent sides. Okay, so here's what that actually means. The two distinct pairs, anytime you see the word distinct, it means different, okay? You've got two different pairs of consecutive congruent sides. Here's the markings I want you to put in the picture. This side is congruent to that side, and this side is congruent to that side. That's what they mean by two distinct sets of congruent sides, okay? Two sides congruent, different set of two sides being congruent. And here's what we're going to do to start off with this one. There's a lot of properties with a kite that we can kind of summarize with one main idea. I'm going to take and draw in the longer diagonal. And again, don't do this on the toolkit, just do this on your sheet of paper. I'm going to draw in the longer diagonal, creating two triangles. How do those two triangles compare to each other? How do you know? Yeah, pretty much, you have the right idea. Here's, if we go back to what we did before with, again, congruent triangles, side, side, side. These two triangles are congruent because of side, side, side congruence, which once again, if I use the idea that if I know the triangles are congruent, then I know all their parts are. Therefore, I know that this angle has to be congruent to that one. I know this angle down here has to be congruent to that one. I know this angle up here has to be congruent to that one, because those two triangles are just reflections of each other. They're congruent. So how could I go through and take all of that information and summarize it in one statement? Here it is. the longer diagonal is a line of symmetry. There's the number one property of a kite. If you draw the longer diagonal in this case, everything on the left-hand side matches up with everything on the right-hand side. Cuts the kite right down the middle. So therefore, everything matches up. That's probably the easiest way to summarize, rather than trying to do every single little part. That summarizes all of that. Okay? There is one other property though that I want to quickly talk about, and that is if I draw in the other diagonal. First thing, this still applies. That longer diagonal will cut the shorter one. This will be the same length as that, okay? Because again, anything on the left matches up with anything on the right. But there's one other thing that I want to take a look at here. One second property, and here's what I want you to see. If I highlight this triangle right here, what kind of triangle is that? Huh? Yeah, I've got two equal sides. This is an isosceles triangle, right? And I've got two equal angles. Again, that idea of a reflection, which means if you think back to triangles, what part of a triangle is that line, other than like a line of symmetry? What do we call that? It is a bisector. That's also true. Something a little bit different, though. If this is the base of my triangle, what's that? It's the height. That is the height of your isosceles triangle. If you look down here, by the way, here's another isosceles triangle right here, just a different one. That's another way of looking at what a kite is. It's one isosceles triangle on top and a different isosceles triangle on the bottom, which means, and here's our final thing that we have here. If we go back to chapter 2, we always said, how do the base and the height compare to each other in any shape? They're always perpendicular. Those two diagonals are perpendicular, okay? Because of the isosceles triangle idea. So the last property I'm going to put in here is the diagonals are perpendicular. And it's based off of the fact that, like I said, we know that's the height of an isosceles triangle, which means it has to be perpendicular. And again, we'll use these properties. I could give you one angle measure in here, and hopefully then you could tell me a bunch of other angle measures based off of these. I could give you a length in this picture, and hopefully you could tell me a bunch of other lengths in the picture, okay? Keep in mind, too, that since this is a 90-degree angle, that means these are four right triangles, and now all of a sudden, Pythagorean Theorem comes back into play. All of that kind of stuff is now back into play because you're dealing with right triangles in a kite. So don't lose track of that. Last thing I want you to do then today is take your toolkit, turn it over, and go to the next page of the lesson packet. And I gave you the whole flow chart basically, where at the top we're dealing with quadrilaterals. That's why it's at the top. Okay, everything on this page is a quadrilateral. But here's basically how it's organized. As you go to the left over here with the kite, what I want you to add in, there's no sides parallel. Okay, put that just like it says in the packet. This put right over here, no sides parallel, right on that portion. And that's kind of how we're organizing this flow chart, if you will, of quadrilaterals. Well, if you go over here to the left, the kite's the only one that doesn't have any sides parallel. If you go down the middle here, you can see on the lesson packet, all of the shapes down the middle have two sets of parallel sides. And you can probably guess what's coming over here to the right. That's going to be the one set of parallel sides. So that's kind of how this is organized. No parallel sides. Everything down the middle has two sets of parallel sides, and everything on the right-hand side has just one set of parallel sides. These are all of the shapes that we're going to take a look at over the course of the next 2 weeks, basically. Okay? We just did the first two together. If you do take a look at the very back of the lesson packet, then again, those 5 problems I had you circle at the beginning, that's a 714 combination with 721. Those two go together as one assignment, those 5 questions. Okay? I will also tell you if you want to start on the next Delta map, it's G23, it's over on the sideboard over there. It's called Proof, Parallelogram Properties, and Factoring. If you want to start on that, you can. You already know some of the parallelogram properties. Some of it will be very short and easy for you. Okay? Other than that, that's what I've got for you today. Your 714/721 assignment will be due by Wednesday.